Okay, welcome back. Um, I'm going to put these three lines together. So syntactically, let's look at this four option, in fact. Let me make it a line together so we can see what's going on. Okay, so I create an object, which is a label GPS, is called LG1. And then I have three other kind of object, and all created with GPSDD. The first one is GPSDD is a G copy, okay, which is created. But the second one is GPS reference, which is a G reference is equal to LG1. And then the third one, which is GPSDD star, this means that GPS star means that this is a pointer. So G pointer is a pointer type. And I basically say LG1, meaning the address of LG1. Okay, so the first, I just want to remind you about your the first semester, EE1520. I just want to make sure that this line I quoted here, syntactically, you feel comfortable, or syntactically, this looks strange to you or looks new to you, you have to let me know. Then I can explain a little bit. Okay, this is just a C style of pointer. Okay, this is the pointer. By the way, the difference between the second option and the third option is one is a C++ style of pointer. This is a C++ style pointer. Okay, this line. And this is the C style pointer. They're actually the same, but syntactically, they look somewhat different. Okay. First, I want to tell you, let's actually go over this one. So assuming I have a function called dump to JSON, so I'm going to put it here. The question I'm going to ask is regarding dump to JSON, which is a virtual function, which to call, which version to call, which is either is GPSDD version or is label GPSDD, label GPS. Okay, so this is just the different version. So when I want to apply, when I want to call on either LG1, G copy, G reference, or G pointer. So first, we have to look at this one. Okay, look at the third option, which I think is simplest one, if you actually understand the C pointer. Okay, so if you see something which is a G pointer, which means that it's not created, because the G pointer is only a reference. It's only the address that the object must be created somewhere else. And then you assign the address into that. So G pointer is just an address of an object, not the object itself. So this line, there's no creation. And the creation is going to be determined by the right-hand side, which is and LG1, because and LG1 is LG1's address, which means that the creation time is going to be determined by LG1. So if you have a line looks like this, it's really about the creation time is actually line number one, labeled GPS. So this one, option 3, is going to call label GPS. Is going to call label GPS. Okay, any question? By the way, if it's a virtual function, it's going to call label GPS. But if it's a regular member function, it's going to call GPSDD. Okay, because it's a pointer. It's not we have determined the creation type. Okay, because of that, remember I said about 2 minutes ago, I said GPSDDN is the C++ syntactic representation about pointer. Therefore, even though you tend to think that GPSDDN looks like a GPSDD, but this one is actually going to call label GPS. Because it's a pointer. It looks like it's not a pointer, it's a copy. No, it's a pointer. Okay. This, by the way, option 2 and option 3, they're the same. They're doing the same thing. They're actually moving the pointer into that. So whenever you see an N, think about it's a pointer, it's an address. And therefore, again, you're referred to LG1, which is LG1 is a object with the created the first one. So it's a label GPS. Okay, option 1 is only one is going to call GPS ED. Why is that? Because it's a copy. It's not a reference. It's not a pointer. It doesn't have the and or star. So you know it is a copy. So essentially, this is equivalent. By the way, I want to write line number 1 differently. This is equivalent to do this, okay? I can make a 2 line. These two are the same. These two, by the way, if you write just one line, say GPSDD, G copy is equal to LG1. This is equal to say GPSDD, G copy, semicolon, and then assign the value. Those two are the same, which means that what it was the creation part, this part was a creation part. So it was created as a GPSDD, which is a G copy. Therefore, it should go with GPSDD. Okay, so I just leave it here. I'm going to upload this code so you can actually repeat what we did, okay, in the class. Okay. Okay, once we've done this, let's try to do some experiment. Let me first make sure that this code can still compile. Okay, I'm programming, we always test it. Okay, it looks fine. Okay, so now let's try to run the code. So let's try to do this. Let's try to do the first two, the original and the copy. And then return. I would just say G copy. Okay, so you can see that the first one is LG1.dump to JSON. The second one is gcopy.dump to JSON. Okay, so we expect that the LG1 dump to JSON should print the label, which the gcopy should not print the label. That's our expectation. Because that's the difference between the different member function, different virtual member function. Okay, so you can see that it's different, right? Original, because if you see the label, that means it's calling label. If you don't have it, that means it's called the base class. dump to JSON. Okay, so this is the first case. Let's actually try different cases. I'm going to change this time. I'm going to change to a reference, cast as reference. So this time I will just say G reference. Okay, like this. Let's see what happened. You see that? Now it's a reference. They both is going to call the same member function, the what do you call that? The derive. Okay, so now I'm going to change one thing. What happened if I modify such that it's no longer a virtual function? So if I modify this and I block it such that it's no longer a member function, I'm doing this. Otherwise, they're the same. Also, the label GPS .h. That's interesting. I already set it to be virtual. Okay, so now it's both of them is non-virtual. Now I'm expecting the second one is going to call the regular one. Huh? It's still doing this? Reference? Does that make sense? Okay. That's fine. I have to do a casting probably. So LG1, oh, wait a minute. I have to do a casting. Let me do a casting for this one. If I do a cast, can I do this? Because it's the reference, I'm not sure I can do this completely, but let me try it. Can I cast into this? Now you see, when I cast as a GPS DD, it actually now pointing to the GPS when I did the casting. So casting became effective to handle this because it is a virtual, because it's not a virtual function. So now I'm going to change it back from the virtual to non-virtual. Then let's see the difference. Let's change this to virtual and also change the other one to virtual, back to virtual. Change this back to virtual. What? When I did this, it's actually unexpected. Okay, I'm going to ask you to think about why when I do this, it's actually going to changing it to the I don't know if you're going, I'm expecting when it's a virtual, when I do this, it's actually going to print the still print the, what do I call it, derived class. But I guess if I do an n, it will, wait a minute, it's already n. If I get rid of this, it should come back. Yes, now it's come back to the 3 label because it's a virtual. Okay. All right. Any question regarding let me just show you this example. I want to give you this is kind of the first introduction to virtual function. So I don't want to go too much detail, but this should be a good example. Let me actually get rid of this too. To let you compare this 4 option, I would just keep it here. So essentially, you can have this 4 different options to represent a object between a pair of base and derived class. And depending on how you casting it, and depending on whether it's a virtual function, so the output, if you actually follow my example, you can actually test it out whether it will call the base class or derived class, all determined by what was the data type that it was created. Okay. Any question? I'm going to move on to the next topic, but I want you to kind of understand this simple example. The best way to learn this is download this code and try it yourself to actually by changing here a little bit, over there a little bit, and see number one, see the code can still get compiled. And then from that process, you will learn about what it is. Okay. And by the way, that's the best way to learn your programming. Okay, to try it yourself. Okay, I'm going to move on to the next topic. Okay, so we have been using this program for you to record your participation, which your program, the client program, is interact with my server program. So I'm start to try to tell you how this really work. So I'm going to teach you how to do JSON remote procedure call. But I have a 3 level of the step. One is called CPP07, which is a JSON remote procedure call. And then I'm going to tell you the next level is CPP08, which is what we call a remote object. And in the remote object, I'm going to use the concept of a virtual function for you to be able to really not just, so what's virtual function is we say we will call the right function at the time the object was created. But then we're going to tell you that we can extend this concept using virtual function, saying that where this object was created at the time is created, but it might be on the other machine. So that's even more interesting. So we talk about created is usually we say created in the same program. But now we're saying that it was created. The virtual function helps us to pointing to a function which was created, but not just created, it was created at another machine. And then we can interact. You can think about today's internet programming that this capability is actually needed. So I'm actually carry the virtual function to a distributed sense. Okay, in this CPP07 and CPP08. And I just want to tell you that furthermore, if you have a chance to go to CPP09, which I'm going to follow that, is proxy object. So CPP09 is that you can actually make this object move around. Okay, so we're going to teach you 3 of this, but we're going to start with CPP07. So first I have to tell you that okay, let me actually still compile it. Make sure I'm still can compile this code. Okay, it looks like it is compiling. By the way, CPP07 is also already on the GitHub. You can actually just download the code and then try to run it. The idea about remote procedure call is that I will make a contract between a client program and the server program on a particular function signature. So I have to specify the function signature. How do I specify that? Let me actually just show you the call first, and then we're going to show how you can actually make the call. So I'm going to show you the program, which is the WR client.cpp. Okay, this is the client side. So usually a function call, we have a caller or callee. Caller is the one who is initiate the call. Callee is the one who actually received the call. The other name for callee under this case is called server when it's running on the other program. So we're actually not just running on a single executable, we're running across. Just like every time you participate, is your program is caller, which my server is the callee. So we can neglect this part. This is just a standard include file. If you include, by the way, EE1520 common, you should have all this. But as a client, I just want to specify that you need to include one thing, which is the JSON RPC standard library HTTP client. So essentially, the programming is, when I say it's a remote procedure call, we're really using the protocol HTTP. So essentially, this is the most common way of the conduct web programming. So we're using web programming, but we're using web programming usually as a browser. You go to the browser, you actually do all kinds of service. But this class, I want to extend your capability that you can actually write a program to interact with a service such as Facebook or Google. Okay, so you include the HTTP client. Okay, so what I'm going to do is that, all right, I'm not going to use the ethicus. I'm going to use localhost. I'm going to use this line, 8309, the port number. So here's a few lines. In order for you to do web programming, you have to know what we call URL. By the way, if you see anything looks like this, HTTP something, 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 this is called Universal Resource Locator. So this is called URL. URL is a name, if you're not familiar with this. URL stands for Universal Resource Locator. Okay, you can think about this is important because when we do web programming, everything software, hardware that's actually connected to the internet is a resource. Everything connected. So essentially what's today's internet is a bunch of resources connected together. And resource locator is useful in remote procedure call because remote procedure call, I need to know where the callee is, where the server is. In your case, when you do the participation, you always use ethicus ngrok.io because that was the URL that connected to my computer right now. Okay, it's a little bit complicated when I talk about ngrok. ngrok, I will tell you when we deal with the project. Okay, but right now, let's just do local hosts. It's probably easier. I'm actually connecting to my own computer, but with a port number, with a different port number. So usually the URL has two portions. One is the host, which is the IP address or a domain name. But after colon is a port number. Okay, port number is a particular number such that my own computer can simultaneously provide multiple service. If I don't have port number, then the default port is usually 80 or 8080. If I don't specify that, then I cannot do web. I cannot do other things. So that's why you can specify port number. So of course, the client server, they need to agree on the same port number. Okay, so that's just, I mean, by the way, this piece of code over here, most of them, this two line, you don't need to learn how to do that. The best way to learn, just copy. You see I'm doing this, you just copy. And then you just change the URL, you can use it. That's the sense of programming. You do a lot of copy, okay? In programming, you always copy. All right, so let me actually tell you what I did. This is the interesting part, is this program, I have a function called remote print. I want to print a message on the server. Okay, so I'm doing this. You see that I have something called my client, which I created with the URL. And I said my client dot remote print. So my client you can think about is an object called WR client object. And remote print is actually another function that's on the other side. So this is called remote print, and I want to print the content. This is another test message. I should change this to EE1520. And then it's going to be spring 2025. Okay, wow, 1 year passed already. All right, so this is the message I want to print on the other program. And the way I call it is my client dot remote print. You can forget about try and catch. Try and catch was just exceptional handling, which I will talk about that later. Okay. I can actually probably block this line. I don't need this. Really? Do you see that the client program is actually very simple, except those what we call placeholder for configuring the remote procedure call. The rest is just treat this my client as an object, and then I'm just calling a function remote print. So that's the client side. Okay, so now let's actually go to the server side. So inside the server side, again, you will see a lot of this kind of placeholder because now for JSON RPC, I have to include WR server.h, I have to include HTTP server.h. So over there, if you remember, the client side was HTTP client.h, over here server.h. By the way, later you will realize it's possible for a single program to acting as both client and server. So for example, somebody call me and I'll call somebody else. Okay, so that's very common. You can be acting as dual role. That's no problem. Okay, and I just add a bunch of popular one. Okay, so now I actually declare a server, which is called my WR server, which I only have a one function called remote print. I call it one function called remote print. By the way, this function is called virtual as well. I actually have to do that in the virtual. I will tell you why. You have to do it in the virtual. Has to be a virtual function. Okay. By the way, there is only two lines. That this line is what? A constructor, because this class is called my WR server. This is a constructor, and then I declare a virtual function called remote print. And then this is a constructor, you can declare that. And then this is the function of remote print. Remote print has two arguments. It's just like when you call. Let me actually go back. Remember this remote print has two arguments. The first argument is a string, the second argument is a string. Let's actually look at the client again. See, this is when you make a call, you see you have a two string. One string is a double quote, and the other one is actually string. Okay, I have to explain this a little bit. So my JSON is a JSON. So there is a one member function from the my JSON class. From JSON value is called toStyleString. ToStyleString means that it will convert the JSON format into a string format. That's why it's called toStyleString. That's why you have this function with two. So this is also a function. And then there's another function called CSTR. It's just converted C++ string into C string. So again, this is just like we say reference and pointer. So there is kind of the transition function for you to convert C++ style of something to a C style of something. Okay. By the way, I think in this case, I don't even need this part. It should work as it is. Okay. Let me just get rid of this. I don't believe I need this. Maybe I will get a warning. I don't know. Let me do this. I'll get rid of this. Okay. I don't think I need that. I think toStyleString is good enough. Yeah, it certainly worked. Why have so many of this? Oh, okay. So now I continue my server. So in the server side, I have this class of a member function called my server. This is a constructor. Now this is a remote print, right? Remote print has two arguments, which is the string. Both of them are string. And then inside the string, you see what I did is very easy. This part is just some of the time protocol. I kind of want to print the time about what is the current time so I can show off saying that, hey, at this time you make a call. So you can neglect anything to do with time. By the way, if you're interested, go to JV time. .h and JV time.cpp. It will tell you all kind of things you can do with Unix time. All right. So inside here, you know what? This part of the code is essentially just try to, this is related to JSON programming that I'm trying to convert it and send it back to the server. So I'm going to just get rid of this part. I don't need this part as well, actually. Result, action. Let me try to do this. This part, I don't really need it. If define, I don't need. I don't. Okay, I want to get rid of this. I want to focus on the stuff we really care. And if okay, I think I get rid of everything I don't want. Okay, result, action. I don't want this one as well. I'm going to, oh, I don't think this one, I need it as well. Okay, and I'm going to change this. And then I'm just printing your JSON, which is the string you want to do. So I say std cout, and I say output from server. And then I'm going to just print your JSON. Okay, so that's what I'm going to do. So the result is empty. I'll probably just put one thing. Result, I said whatever is equal to, I don't care. I do not care. Okay, you'll see my code. When I write code, I always put things very silly. Okay, I just don't care this at this moment. Don't bother me. All right. So basically, whatever I do is I just print the message about output. Because it's a remote print, I don't want to print at the client side. I want to print in the server side for whatever message that was delivered from the client side. Okay, so that's the function. If you get rid of I don't care, there's not much there. Okay. So now I have to do server side. I have to set up the accepting. Okay, so I'm going to configure a function called HTTP server. By the way, this is included in the JSON RPC library. And I have to decide the port number. That's important. Anybody can tell me what was the port number I set up for the client side? I believe it's 8309. 8309. And then I create the server, and then I say I listen, and that's it. You can see this. Whenever you run the program, the only thing you care is the server port number to make sure that you open the same port number between the client and the server. The rest is just a template about whatever you need to fill in. I create a S server. I have to start listening, and then that's it to create a server. So now I'm going to try to compile it and see what happened. Okay, so I'm going to run the client side and server side. So I need two windows. So this is the server side. So I'm going to do W server. Okay, so it means that I already start the server. And then this, I'm going to do WR client. I run the program. There's nothing because I want to print. You see, there's nothing. But let's go to the server side. it say, hey, output from the server content, this is another test message from EE1520 S2025. So you can see that I'm actually making a call across two different programs, even though they're on the same computer because I set it up that way, okay? So that's how it works when you do participation, whenever you write your information, submit, that's how I actually receive your information recorded. That's the mechanism. If you see CPP07, it's fairly simple for us to do this kind of thing. Let me actually just do a little bit more complicated stuff. Let me get rid of the server first. First, if I actually terminate the server, which means that there's nobody to receive this, if you say WR client, it will say, hey, it's an error, because if you look at the error message, it says client connector error, lib curl. You see that curl means a C URL, okay? It's a universal resource locator, but it's under the C programming. It says cannot connect to HTTP localhost 8309, okay? It's actually cannot be connected because why? I terminate the other side. But if I actually turn it on, then okay, fine, it works again. Okay, now you see that it actually print the message. Okay, so let's actually change another perspective. Let me change the port number. Let me get the server changes port number to be something different. Let's change this to 8308. Okay, just change a little bit less. Okay, and then I try to run the server again. And then I try to run the client. It will say, hey, I still cannot connect because I try to connect the URL, which is HTTP localhost 8309, but you're trying to do 8308. So it won't work. So I have to change this back. I have to change this to, so you have to use the same port number. I remember this was very simple, very, very interesting. This was when ChatGPT was first introduced. I use the random port number and I share my code on GitHub. Apparently, the first version of ChatGPT, they read everything from GitHub. And when you ask them the question to write a remote procedure call, they will use the port number exactly I used a few days after my lecture. So that was interesting. Okay, so now I changed to 8309, but just want to tell you, you have a different way to write the whole thing. Let me see, client, you can do localhost, or you can do, by the way, you can do this. These two are the same, in case you don't know. You can say localhost, you can do 127.0.0.1. This two is the same. So the 127.0.0.1, this is IP version 4 address, and 127.0.0.1 always refer to localhost. Okay, just for your information. And now, is my server up? Let me run my server and run the client. Okay, it still get it to work. Get it over here. Okay, so that's the basic. You can see the remote procedure call from the client and the server. It's very simple. You can, the client server, oh, I forgot something very important. I forgot to tell you is that, well, it is not that obvious. Okay, I show you WR client, WR server, you see how they communicate, but I didn't show you how you can actually build the pipe between the client server, especially related to that remote print. So now I'm going to tell you this. So the way it works is I have to start it with this file. This particular file in this case is called ECF36B WR.json. I have to use this file to configure the communication or the protocol between those two. So I have to declare saying that, oh, I have a bunch of functions. You see that it started with a JSON array. So which means that between a pair of a client server, you can have a multiple function. But in this case, I only have one function, okay, called remote print, but you can have multiple. If you look at the master project, master directory, they have lots of them. Let me just go back to the master directory to let me, forget it. Okay, let's do this right now. So I specify a name of the function, which is the remote print. And then the parameter, I call the action and your JSON. I have this two argument, action and your JSON. And then this just represent they're both string. They don't have to be string. They can be object, can be integer, can be Boolean. That's okay. You just specify this to show an example about what kind of data type. So essentially they're using example and to represent JSON. So actually I know what's the data type of that. And then I basically also say what should be return value. The return is always a JSON, by the way. Okay, so once you specify this, now let's look at the makefile. So there is a lot of interesting information that's hidden inside the makefile. So inside the makefile, when you want to make the program WR client and WR server, let's actually look at the makefile. First, let's look at WR client. So inside the makefile rule, you can see WR client depend on WR.O. So when you have this makefile dependency, I remember I told you about this, it triggers another rule in the same makefile. So it will trigger the rule of WR client, which WR client is over here. And WR client is trigger another two rule, which is a WR client.h and WR client.cpp. So we did modify or show you WR CPP. So usually we think that WR client.cpp or WR client.h was some program you already put it in the same directory. But in this case, is a little bit different because WR client.h itself is a rule. So if you go up a little bit, you have another rule, which is WR client. So WR client, this means that WR client is not something you wrote. WR client is you have another program which will generate this WR client.h. In fact, it generates both WR client.h and WR server.h based on what? Based on this JSON file I just specified. So essentially, you use that JSON file to represent the protocol between the client and server, and using this program called JSON RPC stub. So JSON RPC stub is a program which will generate the to.h file for you to do the remote procedure call. So this is a bit complicated, but this is once you get past some example, you will feel, oh, this is really convenient. I can actually just specify how the two programs they need to communicate. This is a communication protocol, by the way. And then I can actually let them to do remote procedure call. Okay, so essentially what we get is JSON RPC stub is the one is actually taking this JSON file as an input. It generates a pair of .h file, which is called WR server and WR client. So let's actually take a look at the code they generate. So let me first make a clean. You see, when I make a clean, I remove WR client.h, WR server.h, because when I roll the makefile, I know those two files are generated. Those two are not my file. Okay. So now if I do make, you see that the first line it does was JSON RPC stub, and using this the JSON RPC JSON file to specify, and it basically create those two H files. So now if you do ls start.h, you will see this two file got generated. I remove it, it generate WR client. So let's look at WR client.h. So the first line you will see in this file, it basically say, hey, by the way, it says already in the comment, it said this file is generated by JSON RPC stub. Do not change it manually. Okay, it basically just tell you, hey, don't do that. And then it has this if not defined, whatever. And then it include, by the way, every single character you see is being generated. You're not supposed to change it. Okay, this is related to another subject, which is I feel for electrical engineering major, this is very important, called compiler. Compiler is essentially understand one form of language, it will generate another form of information or program. Okay, it's very useful. I hope I have a chance to actually teach a course in compiler. That's my favorite. Okay, so over here, you can see that it generate. How does that generate? It's actually generate a class. It generate a class called WR client. It generate a class called WR client and is inherit from the JSON RPC client. So essentially, you have a client that's being defined by JSON RPC, and then I create a client called WR client. Because I specify the class need to be WR client. Let me actually show you how you get the name WR client. Because in the make file, I have this line, JSON RPC stub. You see that the CPP client is equal to WR client. I already tell JSON RPC stub, please, for the client side, call it WR client, okay? Now you have this, sorry. Now you see that the first member function is this remote print. It takes two arguments, action and your JSON. Where did you get the argument? From ECF36B underscore WR.JSON. From there, it actually convert the JSON object into the C++ string over here. Okay, and inside here, they just basically put in the argument action into a JSON. By the way, why is it called JSON RPC? Because it encodes every piece of information into the JSON format. So that's why now you can start feeling that why I'm teaching JSON a little bit different from most people teach C++, because practically, when you do C++ programming, you have to use JSON one way or the other. We use JSON essentially everywhere. Okay, so JSON value P, and then I insert encoding the argument, this two string argument into the JSON format. So now P is a JSON representation about your C++ object. And then you see that I'm actually just using this method called this call method remote print P. And then that's it. That's the remote procedure call. Okay, I need to finish this because I have a CPP 07, 08, 09, the three sets of program to help you to understand the whole thing about remote procedure call. And then you will see how virtual function is everywhere in this three example. Okay, I will see you on Monday. Bye.